right, so where we're at today, you want to be open in your books to page 376, lesson 53. What we're going to be looking at today is performing compositions of functions. Okay? Oh, and we're frozen here, so let's get that all open up. And these types of questions are what I like to call Russian nesting doll questions. Do you know what I mean by a Russian nesting doll? Right. You've got this kind of cylinder-shaped doll, and inside of it is another cylinder-shaped doll, and inside of that one's another cylinder-shaped doll. And you get further and further and further down, they get smaller and smaller and smaller. So basically the reason I refer to it as that is because what you have is you have something, and you're putting something else inside of it, and you may put something else inside of that. We're going to do that with algebra. We're going to take functions, all right, where we have x as a variable, and we may substitute something in for that variable that is also a function. And we may take something and substitute it in for that x, which is also a function. We may even take something and substitute it in for that final x and end up solving it. That's what we're talking about when we're talking about performing compositions of functions. All right. Now, what I want is if I can get somebody to read for me composition of functions on page 376. Eddie, do you have that pulled up there?
Yeah.
All right, could you read that for me?
If fx and gx are functions, the composite functions uses output values from gx as input values for fx. That is, the range values of gx become the domain values for fx. A composite is written fgx or fgx.
Okay, so that's a lot of really complicated lingo, and probably it's not even going to make sense once you've listened to it on a recording or even read it in the book. So what I'm going to try to do here is make some sense of it. If we can scroll here a little bit. Bless you. That's going to be preserved. You're welcome. Thank you for preserving sneezing into our recording here. Okay. All right. So naturally speaking, we have functions, and we might write a function and refer to it as f of x. And function f of x could be something as simple as x squared, right? That could be function f of x, okay? And then we could have function g of x. And g of x may be a little bit more complicated. G of x may look like a slope-intercept, right? It could be something like 2x minus 4, right? It could really be any type of function. It could be a linear function, quadratic function, so on and so forth. And the way these will look whenever we're talking about composition functions is it may look like f of g, right? And what that means is that I'm going to take function g and I'm going to plug it into function f where I see x. So instead of having x in function f, right, I'm going to put a set of parentheses there, and I'm going to put the function g of x inside that set of parentheses. So if I wrote this as f of g of x, that means in the most inner sanctum of the function nesting doll, the x is still going to be x. So if I wanted f of g of x, given f of x equals x squared, and g of x equals 2x minus 4, what I'm going to write is parentheses 2x minus 4 squared, because I'm substituting a set of parentheses in for x squared, and inside that parentheses, I'm putting in g of x, 2x minus 4, and on the outside of that, I'm plugging in the squared. Okay, so far do you follow me? Totally lost. Okay. Do we get f of x? We understand f of x equals x squared. We get g of x equals 2x minus 4. This is this. Okay?
So f of x equals x squared always?
No. Okay? It's just a function in general. Okay? We're just doing this as an example. F f of x won't always be x squared. F of x could have been 2x minus 4, or 3x minus 17, or x squared plus 2x minus 5. Okay? Can you follow me?
Yeah.
All right, so this set of parentheses that we're looking at right here represents this x. Okay? So that's why we see this square show up right here. Okay? And then I'm plugging this inside because it's f of g. So the second function will always go into the first. Okay? Now, in order to solve this, I'm going to FOIL. So it's 2x minus 4 times 2x minus 4. Okay? And then you just FOIL it out. So we get 4x squared, okay, minus 8x. Okay? Let's see. We've got 2x minus 2x times negative 4. It's another negative 8x. And then negative 4 times negative 4, which is positive 16. Okay? So I wind up with a final function on f of g of x is 4x squared minus 16x plus 16. Okay? And so if they ask me, what is f of g of x, this would be my final answer. How many of us we're thumbs down on this, don't get it at all? Okay? All right. So hopefully the more that we go through this, the more examples that we see, the better that we'll get at it. Okay? All right. So I'm going to take a step back because not every time are we going to do f of g. Okay? Okay, I'll try to erase here a little bit. We could also do g of f. Okay, that means we're going to take function f and put it inside of function g. So with this would be 2 from here, parentheses, because it's an x squared, because function f is going in place of x. Hold on a second, I'll get there. Where did I get the 2? Which 2? The 2 out here? Because it's, I'm plugging it in for x. All right, so I'm taking this and I substitute it in for this x right here.
Oh, okay, that makes sense.
All right, so do we understand the first one now? We understand the last question that we did because we did another one. Okay, so now we're going to solve this. Well, we follow order of operations from this point on. So that's 2x squared minus 4. There's nothing else to simplify. Okay? So we get g of f. Sometimes by doing g of f, we understand f of g a little bit better. Okay? Now, let's talk about something else. Now, this one, and I didn't write that next to it, but was g of f of x, meaning that we left this as x here. Okay? But we might want to put a number in. Okay? Let's try g of f. Somebody give me a single-digit number. 2. Okay? Let's try g of f of 2. All right, so because we're doing g is our main function. It's our outside nesting doll. So we're going to do 2, parentheses. And instead of x, though, I'm going to plug in a set of parentheses here, and make that squared, put a set of parentheses there, minus 4. And because we said g of f of 2, that final function, the innermost function, is going to get that number for x. Okay? And our number is 2. Did I lose somebody? Okay. Huh? Okay. All right, so let's kind of start back at the beginning of this. We understood this whenever we did g of f of x, right? Okay? Nothing has really changed here other than the innermost function. Instead of using x, I'm going to use the number that they've given me. All right, so instead of having x squared here, like we had before, right, we're going to plug the 2 in for the x. All right, so this is essentially x squared in here, but I'm plugging in the 2. Does that help? Well, just so that you see that I'm using parentheses for x. So I use parentheses for this x right here, and I'm using parentheses for that x right there. Okay? So 2 squared is 4. Okay? 2 times 4 is 8. Minus 4, so my final answer is 4. Okay? Now, what we notice with this, and what we should have noticed whenever we did f of g of x versus g of f of x, is did I get the same answer for those things? Did I get the same thing when I plugged g into f as I did whenever I plugged f into g? No, I got 2 very different answers. So the 2 things are not commutative. Okay? Unless the functions are inverses of each other, I won't get the same answer. Okay, do you follow me? All right. The other way that they may represent our function is if they might do something like this. Okay? It's the same thing as g of f of 2. Okay? It's just a different way of writing that. Follow me so far? Okay. All right. Now, they can even go as far as to take another function. Let's say we had h of x equals, let's say, 3x. Okay? They might ask me, what is f of g of h of x? Right? So that would mean that the main function, okay, and let's see, I'm going to try to scroll down here a little bit. Okay, that the main function is still x squared. So parentheses. Okay, I'm going to come out here and it's going to be g is going to go in next. 2. Okay, and inside that parentheses 3x minus 4. I'm going to finish up that, and then I'm going to square it. This is what f of g of h of x would look like, okay, before I've solved any of it. Did I lose about half of you there by taking 3 sets? Okay, so let's look at this. This is f of x, right? This is g of x. And this is h of x. Do we see it? Okay, I'll give you a chance to write that down. Okay, and then we would go from order of operations to solve that on from there. So following order of operations would be 2 times 3x. I'm going to distribute inside. So it's going to give me 6x. 6x minus 4. Okay, I can't combine any like terms. Then I square it, which means I'm going to FOIL. All right, so I'm going to get something like 36x squared minus 48x plus 16, right, whenever I FOIL all of that out. All right, so from here, hopefully you've got enough of that written down. What we're going to do is we're actually going to go to our work and try to answer some questions. It may or may not be as difficult as what we just saw. Okay? Here, we've got f of x equals x to the 5th. G of x is 1 plus 3x squared. We want f of g of x. Are we going to substitute anything in for the final x? No, because they didn't give us a number, right? All right, what is the large function? What is the function I'm putting things inside of? X to the 5th. All right, so I'm going to start off by doing a parentheses with a 5 on the outside, because that's all f of x is it's an x to the 5th, right? Okay, inside of that, what should I write? 1 plus 3x squared. And that's all they want. Okay? This is f of x. This is g of x. Okay? F of g of x. Okay? Had they told me that it was, say, f of g of 3, I would just go in and I'd plug in a 3 where I see that x, and then I would solve from there. Okay? How many of us went from maybe a thumbs down and we're about in the middle now? Is anybody still all the way thumbs down? I don't get any of anything that you've said. Okay, I don't see anybody in that position, so hopefully we can kind of move on from here. All right. Now, just so you know, that even though that you guys are in this class that's being recorded, I'm going to send this recording to you. So if you miss something, you can go back and watch it, go back and listen to it, see it again. Okay. All right. This next one, f of x equals x cubed. G of x is 4x plus 3. You want to be really careful because we'll have a tendency to assume that the first function is the one that we're going to plug things inside of. That's not necessarily the case here. Okay? You want to look at our notation to see what's the big function, who's going inside of who. Okay? All right. So the bigger function is what? G of x. All right. So what am I going to begin to write? Not 4. 4. Let's start with 4. 4. Okay, 4x cubed, I think I heard somebody say. Okay, plus 3. Okay, so I'm putting a set of parentheses where the x is in 4x plus 3. All right, but did I miss anything? I forgot to do what? I need to change that x to a 3. All right, so because now it's all numbers, I can get an answer here. What's 3 cubed? 27. So I got 4 times 27 plus 3. What's 4 times 27? We're just following order of operations here. 108 plus 3, 111. So we're getting our answer right there. Okay, a little bit easier, right? Okay, and even though it requires us to do an extra step whenever they give me an f of g or g of f where it gives me a number, it actually works out pretty nice because it allows me to get an answer. Okay. All right. Let's see. Number 3. Number 3, I'm kind of going to do for you because the way that's worded could be a little confusing to us. All right. The oven temperature of baked goods at elevations over 3,500 feet should be about 25 degrees Fahrenheit higher than the temperature used at sea level. We want to write a composite function to represent the oven temperatures at elevations over 3,500 feet in Celsius. The conversion from Fahrenheit to Celsius is given by a function that we're going to see here, where T is the temperature in degrees Fahrenheit. What we want to do is we're going to write our composite function, but essentially what we're coming down to is it's going to be T, let's see, minus, T plus. We're going to start off with T plus because it's 25 degrees higher. Okay, so we're going to add 25 and then subtract 32. So we're looking for what 25 minus 32 is. Not 7, negative 7. So my answer is going to be 5/9, okay, times T minus 7, and that's going to tell me the temperature difference. What is the temperature in degrees Fahrenheit to bake something at 3,500 feet? So once I know what the temperature is in Fahrenheit, right, I'll know what it should be in Celsius. Okay? So we should get an answer that's going to look like this right here. I'm not saying that you'll see that on a test, but just so you're aware of how that's being done. Okay? All right, let's move on to number 4. F of x is 3x plus 8. G of x is x squared. H of x is negative 5, and that's why, or negative 5x, and that's why I wanted you to see a 3-function composite. Okay? Find the composite function of f of g of h of x. So what is the largest function? What's on the outside? Close. 3. Okay, so let's start with it. 3. What? Okay, so we got to drop the x, right? Because we got to put something inside of it. What am I using instead of x? No, what am I always using instead of x whenever I'm trying to put something in? Parentheses. Parentheses. So I have 3 parentheses. All right, because it's f of g, what needs to go in next? No, it's f of g. X squared, but is something going in for that x? So I need to use a parentheses. All right? Now can I put in the h of x? What is h of x? What is h of x? Negative 5. So negative 5. Am I doing f of g of h of something, or is it just x? Just x. All right, so we're going to leave that as x. So that's my h. I can close up that parentheses. Does there need to be anything outside of that parenthesis, squared, so that we're finishing off g of x? Now what's next? A parentheses, right? So that's going to finish off that, plus 8. Okay? So that is where we would start with the composite function of f of g of h of x. Now, let's go on down here and finish solving it. What is negative 5x squared? Well, what's negative 5 squared? 25. No, because negative 5 times negative 5 is, all right, so we got 25 what? X squared, very good. Plus 8. All right, now what do we need to do? Distribute. Okay, what's 3 times 25x squared? 75x squared plus 8. Can I combine any of those terms? No, so I'm left with A as an answer, 75x squared plus 8. Okay? All right. Number 5. If f of x squared equals 2x squared, 2x squared minus 6, g of x is 4x, then what is f of g of 3? All right. What is the outside function? F. Okay. So f starts with a 2. Now what? Parentheses. 4. Good. No. Squared. Good. Squared minus. Okay. All right, so let's go from here. What needs to be solved first? Right, so we're inside the parentheses. What is 4 times 3? No, because it's outside the second set of parentheses. So 12 squared minus 6. What gets squared? The 12. So what's 12 squared? What? 144. Okay, be careful you're not multiplying 12 times 2. Okay, what's 2 times 144? 288. Minus 6. 282. Okay, 282. A is our answer. Okay. We need to get probably at least one more question done. I think that's where we got maybe with the other class. Okay. 7, 8, 9, and 10, you guys have the answers to that in your answer key at the bottom of this. We've got f of x equals x squared. G of x is negative 4x minus 5. We want f of g of 5. What's our main function? F. So I'm going to start with what? No. Parentheses. Now what? No. Negative 4. Parentheses. 5. Because. All right, there. Negative 4, parentheses, 5, what? No, I don't need another set of parentheses. Minus 5. Closed up the parentheses, because otherwise, if I'm just squaring the 5, that's going to mess that up. So what do I need lastly? I need to square the whole thing. All right, now we follow order of operations. Inside the parentheses, what's negative 4 times 5? Negative 20 minus 5, what's negative 25 squared. What's negative 25 squared? Should be a positive something. It's negative times a negative is a positive. 625. 625. All right, do we feel better about this than when we saw those first couple of example questions All right. So, like I said, 7, 8, 9, and 10. The answers are at the bottom of that. We're kind of out of time as it is. If you have questions, let me know. Like I said, I'm going to try to send this to you. I'm going to have to try a couple of different methods to make sure everybody can open it. But I'm going to hit stop